Before we start talking about molecules, I want to go through an example involving something a little bit more concrete, something a little bit more tangible. All right? And so what we're going to do is we're going to consider an example where we're just flipping two coins. Okay? And so imagine that what we're doing is we're just flipping a penny and a quarter. So two different types of coins. And the number of coins we have is 2. So I'm going to say n is equal to 2. Alright, and so when we flip these coins, they could either land heads or tails. There's only 2 different outcomes per coin. Right? And so what we want to do is we want to analyze the different outcomes that we could get when we flip a coin. Okay? And so to do this, I'm going to make a table where I just write outcome. And one column is going to be the outcome for the pennies, whether it lands heads or tails. And another column is going to be for the quarter. Okay? And then, in this last column, what I'm going to do is I'm going to count the total number of heads that are up for each of these different types of outcomes. Okay? All right. And so, let's consider outcome A. And in outcome A, what we would get is that a penny lands heads up, and the quarter also lands heads up. Right? And so the total number of heads up that we have is 2. Right? Both the penny and the quarter are heads up. For outcome B, what we could get is that the penny lands heads up, but the quarter lands heads down, or tails up. In this case, we would only have 1 heads up. The reverse could happen as well, where the quarter lands heads up, but the penny lands tails up. In this case, we also only have 1 total heads. And the last outcome would be the case where both the quarter and the penny land tails up. And so in this case, there are 0 total heads. Okay? All right, and so, these are the different outcomes that we could get if we just flip, a penny and a quarter at the same time and look at what face lands heads up. All right, and so the way that we would describe each of these outcomes is we would call each of these different outcomes of our pair of coins as a microstate. Okay? Alright, and so in this context, the microstate specifies the state of each coin. Right? So it gives us precise information about, what each coin, the quality of each coin. And so microstate A, both the penny and the quarter are face up. Microstate B, only the penny is heads up. Microstate C, only the quarter is heads up. And microstate D, both the penny and the quarter are face down. That's what the microstate refers to. All right? This is in contrast to what we call the macrostate. Okay? And so, if we consider, not the specific value or quality of each coin, but we just consider a quality that describes the entire collection of coins. So in this case, if we just look at, what are the total number of heads up we have, that's what we would call a macrostate. Okay? And so, if we take a look at our column for heads up, in this column, we see that for this collection of 2 coins, there is only one way of getting, 2 heads. Right? And then there is only one way of getting, 0 heads. But in both outcome B and C, we saw that both of those outcomes we got 1 head. Okay? Alright, and so for this system of 2 coins of a penny and a quarter, we see that, if we were just looking at how many coins were face up, the state, the macrostate in which 2 coins were face up, there's only one way of getting it. The macrostate of 0 coins being face up, there's only one way of getting it. And the macrostate of getting 1 coin face up, either the penny or the quarter, there's 2 ways of getting it. Okay? And so 2, 1, and 0 are the different macrostates for the system. All right? And just to reiterate, both outcomes B and C belong to the same macrostate. Okay? Right? And so a microstate is the, describes the specific state of each of the coins. And then the macrostate is just kind of like a general category that each of the different microstates can fit into. Okay? All right, so that's the difference between micro and macrostates. The last thing I want to define is the term multiplicity. And so the multiplicity, all that is going to be the number of microstates that belong in each macrostate category. Macrostate is multiplicity. Okay? And we abbreviate multiplicity as omega. Okay? And so, if we talked about the multiplicity of the macrostate where we had 2 heads face up, the multiplicity of that macrostate would be 1. If we talked about the multiplicity of the macrostate in which we only had 1 head face up, that multiplicity would be 2, right? Because both outcomes B and C had just 1 coin face up. And the multiplicity of the macrostate where we had 0 heads face up, that would be just 1. Okay? All right, and so if we add the total number of different types of microstates that we get, right, which would just be a sum of the multiplicities of the macrostates, we would get 4, right? There's 4 different types of outcomes that we could get with our 2 coins. All right? And really, the way that we would calculate that, just as a shortcut, would be 2 raised to the power of 2. And the reason the 2 is in the exponent is because that's the number of coins in our system. Okay? But that's, that's a detail. That's not that important. The main thing I just want to get across to you is that this omega, this multiplicity, is just the number of microstates that are in each macrostate category. right? And if we know the multiplicity for each macrostate, and we also know the total number of different microstates that we could get, we could also calculate the probability that we would observe, different sorts of macrostates. Or for this system, to be more concrete, what's the probability that we would observe the instance where we have, either one head face up, two heads face up, or zero heads face up, or more generally, what's the probability we have k number of heads face up? To calculate that probability, what we would do is we would take the multiplicity of a macrostate that had k heads up, and we would divide it by this overall multiplicity. Okay? And so, the probability that we only have one head face up would be omega of one head being face up over omega total, right? And so this was 2, and omega total was 4. And so the probability that we would observe, one head facing up would be 0.5 or 50%. If we take a look at what's the probability that we would see two heads face up, that would be 0.25, right? Because it would be 1 divided by 4. And the probability that we see 0 heads face up would also be 0.25, right? Because all we did was just take the multiplicity of each macrostate and then divide it by the total multiplicity of our system.